Welcome. So we're going to answer this question before us. It says the function with the rule f of x is equal to mx plus 2, where m is less than 0, has an inverse function with the rule this, where a and b are real numbers. Which of the following statements is true? Now, the first thing that I want you to recognize here is that this is a tricky question that requires some critical thinking. And whenever you encounter a multiple choice question that does seem a bit involved, you need to remember you really don't want to be spending any more than 2 minutes on it. Now, there are some instances where you're thinking, hey, it's taking me a bit of time, but it might take me 3 minutes. Well, that's fine. Keep going. If you think that you're being successful, keep going with it. But if you just feel yourself burning time on it and just kind of wasting time, you're making no progress on it, you need to put an asterisk next to it, guess, and then come back to it. That's what you need to do. You don't want to just stay there wasting time. The way that your Year 12 exam is created, the way that your tests are created, is we try to give you, on average, 1.5 minutes per mark. That's what we're aiming for, and that's what you need to get your head around. Okay, so let's look here again and spend some time just critically thinking about this question. So we're told that we have this rule, mx plus 2, where m is less than 0. That is very important, because if I was just to give this a quick sketch, I know that this is a straight line, and the fact that m is less than 0 is telling me I have a negative gradient. That means that it's going down. I also know that it's shifted 2 up. So that means it's going to look like this. I've shifted 2 up, and it has a negative gradient. Now it says I need to find the inverse function, and it has this rule to it. Well, I started off with y is equal to mx plus c, and now I need to find the inverse function of it. If I swap my x's and y's around, and then solve for y, that means my y is going to be x on m minus c on m. And the way I might like to write this is 1 on m, x minus c on m. And now we know that the inverse function is in this form right here. It is in the form ax plus b. That's the form that we've been given, ax plus b. So as you can see, if I just grab out a highlighter here, 1 on m is my a value, and then negative c on m is my b value. And I now need to figure out which of these are going to be true for it. So let's go through these. Okay, so I have 1 on m is equal to a. Well, I know that m is less than 0, right? Because we were told that at the very beginning, that m is less than 0. Therefore, a has to be less than 0, because 1 divided by a negative number is a negative number. A is less than 0. So if I now come up here, you can see that means a is out, because a is greater than 0. B is good, C is out, D is still in, and A, look at that, 1 on M. That looks promising because that's what we have, but we don't yet know that B is equal to negative 2, so let's hold off. Okay, the next thing that we know is that negative Cm is equal to B. That's just what I've highlighted in blue there. Again, I know that M is less than 0, so I've got a negative number divided by a negative number. That means I'm going to get a positive out. That means B has to be greater than 0, because I've got a negative divided by a negative. B has to be greater than 0. A has to be less than 0. We come up and we look at our options. That means B is out. That means D is good. A is less than 0. B is greater than 0. We can't say that B is negative 2. We don't have enough information there. But what we can say is D is true. So you can see the thinking that would go behind a question like this. And of course, I'm spending a bit more time going through it. You would have to do this a bit more quickly in a real test. But with practice comes perfection.